Alright, good afternoon. Today is another episode of Dr. George Logic. Today we're going to get into Karnaugh maps a little bit more. I'm going to work with some don't cares. So let's get into it. Okay, so let's begin with solving this question. Find the minimum SOP of the function a, b, c, d. The Karnaugh map is given here. So the first thing we do, right, we try to actually find the least amount of big circles of ones, right? Now, in this case, you have to notice that there is a don't care case, right? That don't care case is here, right? Now, if we were to actually circle the ones without don't cares, we would actually have to circle these two ones together, and that will give us a three variable expression. Then we'll circle these two ones together, and that'll give us a three variable expression, and then we circle these two ones here, and that will also give us a three variable expression, and then these two ones here will give us a three variable expression. The good thing about don't cares is that we could actually utilize them. We could determine whether we want the don't care, the x, to actually be 1 or 0. So we actually utilize it as 1 strategically to be able to get bigger circles of ones, hence reducing the expressions for those circles from three variable expressions to two variable expressions, right? So we are going to strategically use these don't cares as ones, hence allowing us to, in this case, circle these four ones. And then using the same, because we could recircle ones, we are going to use this don't care now also to enclose the four ones here. So we are going to get two circles of four ones each if we utilize this don't care as a 1. Remember, if we don't utilize the don't care as a 1 and we leave it as a 0, then we would have 4 three variable expressions, but that's going to actually result in a very long expression. To avoid that, use the don't care as a 1, and we end up with these two big circles of 1s, each giving us a 2 variable expression. So once you complete the circling process, the next thing is to actually find the expressions for all of the circled ones. So let's do that. Alright, so now that we circle the ones, all we have to do now is find the expression for each of the circles. Right now I'll be using the term circle or squares interchangeably. It's the same thing, square or circles of ones, it's the same thing. So the first thing, let's look at this one here. Alright, this square, right, and I showed you all in a previous episode how to find the expression for those squares of ones or circles of ones, right? So we have to look and see what variables are common to all the ones, and whatever variable is common, that is going to represent that circle. So for this circle over here, or this square, if we look in this direction, all of them basically have b equals to 1. And the expression for b equals to 1 is b. Looking downwards, we see what is common to both of them is c equal to 0. And c equal to 0 gives us an expression c prime. And then if we look at this one here, what is common to all of them in this direction is a equals to 0. That's going to give us an expression a prime. And if we're looking downwards for this circle, so a square, what is common to both of them is d equal to 1, right? And d equal to 1 is, think about it, d. So therefore, our minimum SOP for this expression for f, a, b, c, d, given this Karnaugh map, will be f, a, b, c, d is equal to b, c prime plus a prime, d. And that's our answer. And you see how easy that was? So it's pretty easy to work with Karnaugh maps, even with don't cares. It's just a matter of finding out what is the most appropriate use for those don't cares. How can we actually utilize those don't cares to actually minimize the expressions for any of the circles that we would have had without don't cares, and that is as simple as it is. So I'll see you all on another episode of Dr. George Logic. I'll see you all.